Greetings. We continue our discussion of interest, in particular compound interest, as it relates to solving different mathematical problems. You may recall the first lecture that we did where we were trying to find A, the amount of the account in example 1. We're going to move forward to look at a different type of example today using the same equation, and hopefully we can move quickly through it. This says, assuming quarterly compounding, determine how much was deposited into an account if it reached $12,300 over the span of 4 years with an interest rate of 3.25%. And we see here we're assuming quarterly compounding. So just to remind us of the actual compound interest formula, you may recall that we had this notion A equals P times R over C plus 1 raised to the power of C times T. And you can look at the first lecture to see what each one of these components stands for. It's pretty self-evident, at least some of the values maybe, but we'll use this formula this time not to solve for A, but to solve for something different. So again, assuming quarterly compounding, we have this scenario. Now, the buzz term or phrase we're going to use in solving this, you see here, assuming quarterly compounding. Show you here. Right? So now that's the telltale sign to inform us of which equation we're going to use. So anytime it's monthly compounding, quarterly, daily, anytime you see that compounding phraseology, that means we're going to use the particular formula that we just discussed. All right? So determine how much was deposited into an account. Oh, how much was deposited? That sounds like we're looking for P. Yeah? So P equals question mark. Into an account if it reached 12,300. So if it reached 12,300, then that means that's how much was in the account after it was all said and done. And that's what we said was what A represented. How much is in the account after interest accrues? Over the span of 4 years, our T is 4, with an interest rate of 3.25%. Okay. Now, there's one thing that's not stated explicitly, but again, if it's telling you assuming compounding, it's telling you how frequently compounding occurs. It's not monthly, where the C would be 12, but in this case, it is quarterly, right? And basically, how many quarters are in a year? There you go, 4. Based on our discussion of what C means, how many times does interest accrue in that 1 year? If it's quarterly, then the answer is 4. So we see here, if we put into the formula, is A equals, there's the P, times. Now this R, 3.25%, move the decimal twice to the left, and we have 0.0325 over C. Well, what is our C in this case? 4 plus 1 raised to the power of C, which is 4, times T, another 4, okay? So just understand that these two 4s represent two different things in the exponent position. I know we see 4 times 4, but one of the 4s is the C, and the other 4 is the T, okay? Now we want to solve this, and this is a little bit more involved than solving for A. And again, we're still using order of operation, right? So we're going to maybe do this part in parentheses first and then raise it to that particular value there. So there's a number of ways to go about approaching this. If you are having some problems doing these types of problems, just take your time. You don't have to rush. You may not be able to put everything in a calculator at one time. Just go at your own pace. For example, this is what I'm doing. I'm just going bit by bit. And I'm solving this part first. The 4 times a 4 is that 16. Yes? And then if I just have to sort of keep going one step at a time, there's nothing wrong with that. P times. Now you can do the part in parentheses. There, use your calculator. I have a calculator here. I can just kind of put it inside of here. 0.0325 divided by 4 plus 1 equals. Okay, So don't feel ashamed if you have to do that, right? Just make sure you're getting the right numbers inside of here. So it looks like that is, so everything in parentheses is 1.008125. Now you may get to a point eventually where you can do all this stuff on the calculator in kind of one fell swoop. And if that's the case, that's fine, right? But essentially you're going bit by bit by bit. So we have this value 1.008125 raised to the 16. So I will do that on the calculator just to show you what's going on here. Equals. So I'm going to go back to the calculator. And there's my answer there already. I'm looking at it. So I'm going to raise X to the Y key. And this is calculator.net. Raise to the, right? Now I can put in the 16 right there. Equals. Now, I'm not going to write that long number. I can if I want, right? But the idea is if you do that, don't round off. Write as many numbers as you can. As a matter of fact, I'm going to show you. I want to show you this. Just 1 second. 1382303. I'm just going to write part of that number inside of here. I'm not going to round it off, but I want to show you what's going on. We have P times 1.1382303, okay? But what we have here, you see how we have 12,300 equals P times this number right here? Essentially, to solve for P, what we're doing is dividing both sides now by that same number, 82303, and divide this by the same number, 1.1382303. So on the right side, this cancels out. See that? And we're left with P on the right and whatever that expression is on the left. But if you're using a calculator, notice here, depending on what calculator you have, you can really make your life that much simpler because we're looking at 1.1382, whatever that long number is. And so notice here, in order to solve the final answer, is going to come from doing this operation right here. 12,300 divided by that number. So if I go here to calculator, I'm going to say, while the number is there in the calculator's memory, I'm going to say 12,300 divided by, now look here, answer. You see how when I put in answer, it called upon that number that had recently been stored, 1.138, blah, blah, blah. And now it's giving us the answer of 10,806.25, just round 2 decimal places when it's finished. So what do we have here? We have P on this side that's left over, and then over here we have 10806.25. Okay. So that's the answer that we're looking for. So you will get more experience in solving these every time you do another problem. But I did this intentionally, going step by step by step, as opposed to just throwing it in a calculator. Again, you may get to a point where you feel comfortable, even from step 1, just saying 0.0325 divided by 4 plus 1 raised to the 4 times 4, and you get that answer. Then you can see that is 12300 divided by answer. But I think doing it this way, step by step, you're able to visualize why we were able to say, for example, 12,300 divided by answer, and it literally put that number in for the answer by itself without us typing it in there. So at the end of the day, the answer to the question is how much was deposited? $10,806.25 for it to have reached 12,300 over the span of 4 years. Okay, so this is the case where we're using the compound interest formula, but this time we're solving for P. All right.